it over to Jeremy Mcgill.
Okay. I normally make most of this up as I go, and it's more difficult now that Morgan is is on the program for fencing schools. So Morgan will keep me honest. I'm not going to make up as many things as I normally do. So she got into the weeds, literally got into the weeds pretty deep, and I'm going to give you a view from the farm level. So there are some technical slides in, and we're going to breeze right through them. And we're here all day, me and my two counterparts, and I think Morgan's going to be here till at least a little bit after noon. So feel free to ask us questions and throw scenarios at us. And we're going to try to do some pretty cool stuff in the field. We're going to intentionally make some shorts on the fence and show you some differences. It's sometimes difficult to make things go wrong, even in a known environment, but we tried our best to make a few things go wrong. We've got some other parts out there that have been wrong for a while that we're going to point out. So hopefully, at the end of the day, as you're either on farm or working with your producer clients at home, you can have a little better understanding and just where to look for some of the problems and get more comfortable with it. So the first thing we have to realize with electric fence or power fence is it's a psychological barrier. It is all in the mind of the living thing that is touching the fence wire itself to getting the shock. Big difference between electric fence and the physical barrier of woven wire, barbed wire, plank fence. That type of material is physically restraining animals. With what we're doing with whether it's polywire, multi-strand, high tensile, tape, that is all based upon an effective psychological barrier. That animal, the animal, neighbor's kid, whatever, you psychologically do not want to touch that wire because there's a pain associated with it. And those animals have to associate the pain with touching the wire, which is part of a good training program to train your animals, and we'll show some examples of easy ways to do that later. But it's a very effective psychological barrier. Now, what we've learned over the years is we can take that psychological barrier, build it correctly, and control all of these animals. In most every zoo across North America and many around the world as an effective psychological barrier. And the cool part is when we do zoos and theme parks and things like Animal Kingdom and whatever, the electric fence is disguised as weeds and grass and vines, and typically that's the primary barrier before the elephants or the gorillas at the Louisville Zoo or the giraffes at Nashville Zoo. That's the primary barrier before they hit that physical barrier that is normally some type of decorative, appealing to the eye fence, whether it's cable or even a moat can be used as a fence. But we're using a psychological barrier to control these animals. And I guarantee you the folks at these zoos and theme parks are not cutting corners like we do as producers, or some of your clients or producers would probably not do in any of the counties that are represented in West Kentucky, but I know in some parts of the state they like to cut corners. The zoos are not going to cut corners. You're not going to find old quart oil jugs nailed to trees at zoos to use for an insulator. There may have been somebody in Crittenden County that did that once. I'm not sure. So if we can control these animals, is there any reason why we can't control these animals? And the answer should be no. There's no reason why we can't control some cows grazing behind a single strand of polywire with a single strand of high tensile or polywire running crossways. If the fence is built properly, if we understand how the fence works, and if we don't take shortcuts. And I'm a producer myself, and I'll guarantee you if there's a shortcut that can be taken, I've probably tried to take it in the past and have learned from many, many mistakes of taking the wrong path myself. And what's going on in this photo is we're taking a single strand of high conductive polywire with tumble wheels, which that fence tumbles as you move it. So on the other side, next to those trees, there's another cross fence, single strand cross fence. And so one day, you would take this reel and put tension on it and walk, and those tumble wheels would roll, and they're always, the two legs on the ground are always insulated because of the gravity. And then 3 days later, 2 days later, whenever your next feeding is, you take a reel just like that on the other side and you move it, so you're zigzagging it. Easy way to utilize stockpile tall fescue, which is what's going on here. I think this picture was a December picture possibly. But that's what's possible with a proper built electric fence. You wouldn't have to use tumble wheels. You could move tread-in post and poly wire. But something like this setup, fairly low-tech fence, but if designed properly, you can take 3 or 4 tools and you or your producers can change the whole dynamics of their operation. I guess really that's the heart of what we're trying to accomplish today is give you some ideas on how to troubleshoot and design a system where you can actually see the dollars add up. Because everybody knows if you can graze stockpile fescue in December instead of feeding hay, then you're saving money. So electric fence is going to change the dynamics, and if you utilize temporary fence to let you make the decisions and not your cattle, then you can see the dollars add up. So when designing a system and planning a system, you have to answer a few questions first. What are you keeping in? What are you keeping out? How big is the system? Is it going to be all permanent? So is it all permanent cross fences like we'll see out here in this demonstration area today behind the station? Or is it going to be a combination of permanent fence and temporary fence to utilize for some type of managed grazing system? Regardless of the type of system, portable or temporary or a combination, you have to remember that power fence is a system. And so every system has components to it. It doesn't matter what type of system, if it's an electrical system in a vehicle, if it's a system on a tractor, it has components. Power fence has components, and every component of the system has to work together or the system fails. So the basic components are the Energizer, the fencer, the hot box, whatever you want to call it, the ground system. We'll get pretty deep into the ground system today in the field, and then the insulated fence system itself, your posts, wire, insulators, cutout switches, joint clamps. That's a system within itself. All 3 of those have to be properly considered, planned, and built. If you take shortcuts on one part of that, the whole system can fail. And then also lead out. We'll talk more about lead out in the field. That is the link that puts a couple of those components together. So it has to be designed properly. Morgan hit on this. She explained low impedance in detail. Always use low impedance with poly wire. And it's hard to find solid state energizers or high impedance energizers anymore. There are still some available new, but if you or your producers have non-low impedance energizers, then they are not designed to be used with poly wire because you can melt your poly wire. Blade of grass touching the poly wire, eventually enough blades of grass, then where the power's on that wire for a few thousandths of a second too long, it can heat the poly wire up, poly wire melts. You're no longer in control of your operation, and the cattle just roam free within the boundaries. So always use low impedance with poly. Here's the hard one. What size Energizer? How do you compare? How do you compare within brands? How do you compare across brands? The answer is hard. We can look at manufacturers' ratings. Some companies will give a mileage rating, acreage rating, multi-wire, single wire. Some don't specify which one. Stored joules, output joules, super shock them, burn their hooves off hot, high power, super power. You can see all these, and these are marketing terms, believe it or not. On the packaging, it'll give a rating. And then it's the crazy part of New Zealand versus US ratings. So New Zealand is essentially the home of the electric fence Energizer, the home of electric fence. I don't know what it is now, 82 or 83 years ago, our owner's father pioneered the first electric fence Energizer, and that was in New Zealand. And so that's where the heart of the industry started from. And so you have a lot of companies like us that started in New Zealand but have moved into the US and North America and other markets around the world. And the crazy thing is, in New Zealand, they're extremely efficient and very effective with the systems they build and design on farm, because they are relying on that to change the dynamics of their grazing operations. They're a highly agrarian economy. So the New Zealand ratings will be much more conservative than the US ratings on the exact same Energizer. When it comes to the US or Canada or North America, it will get put into a different packaging, and it'll be a difference between 120 volt or 220 volt, but still the transformer puts it back down. As Morgan mentioned, the transformer puts it back down into very low amps, high voltage status. So you take the same Energizer from one continent to the next. New Zealand may say that this Energizer is rated for 30 acres. You bring it to the US and the rating all of a sudden becomes 120 acres. It's the same components. So why is that? It's marketing. In the US especially, we always try to outdo the next company, and it's always bigger the better. So what does that mean? You've got all these ratings, and they're essentially all marketing within companies. So let's take a couple, for example, and put them into a real world perspective. If we take those mileage ratings, because everybody, it seems like, especially in Kentucky, producers like to think of Energizers, well, that 25-mile fencer, the 50-mile, or I bought one of them hot ones for $250, they'll do 100 miles. Will it really? Put it into real-life math from a perspective of, let's go across the river into Missouri. Easy place to find big, nice, square sections of land. So if you're flying over in an airplane, you see all these big squares, and a section is a mile square. It has 640 acres in it. That's a square section. So if I get in my pickup truck in Missouri on a square section and start at the beginning and drive around it and come back to the beginning, my odometer says 4 miles. So it's 4 miles around 640 square acres. Now, it could be a lot longer than that if it's a long rectangle, some kind of funny shape. But for consistency, let's say square. So it's 4 miles around 640 acres. So what that tells me, if I believe the literal marketing statement on the Energizer of a 4-mile fencer, then I should expect to be able to take it to Missouri on a square 640-acre farm and electrify that system properly. Right? So that's what I should, if I take it literally, that's what would happen. So take a couple steps further. What about a 100-mile fencer? Oh boy, that one's hot. 100-mile fencer. $250, $300 in some cases. I should be able to take it out to New Mexico on a 400,000-acre square ranch. And if I drive around that 400,000-acre New Mexico ranch and start at the beginning and drive around the end of it may take a while, then when I get back to the starting point, my odometer would say 100 miles. Now, will $300 from the farm store properly electrify 400,000 acres? You make the call. Probably not realistic. What we can say, though, is hopefully within brands, brand A that has a 25-mile fencer and a 100-mile fencer, the 100-mile fencer is probably 4 times the power, 4 times the strength of the 25-mile. Will it do 100 miles of fence? Probably not. But don't compare cross companies. And yes? Sure. Yep. Nobody knows. It's all relative to that marketing within that company. Joules.
If it's stored joules or output, what's the difference?
So stored joules remains constant. And Morgan got into the weeds pretty deep on that, on joules as a concept. Stored joules remains constant. We can take any Energizer in the world from any company and hook it up to an analyzer, which is not a fence. You can't test joules with a fence tester, but you can test joules with an analyzing machine and be held accountable as a company. This Energizer has 28 stored joules. It has 4 stored joules. Output joules are only specific to the load on the fence because your curve can do this. You can have a power curve, and adaptive control Energizers will adapt up and down, which is a different set of technologies. But output joules vary according to the load on the fence. You'll never get, on a 28 joule Energizer, which is what's on the station, you will never, ever, ever get 28 joules of energy on that wire. But you have the capacity to store 28 joules. You may get 18 joules on that wire at a specific load, or you may get 21 joules of output at another specific load. So your output joules vary according to the load. Stored joules remain the same. Therefore, it makes it, and I think it makes more sense to compare stored joules to stored joules to stored joules because that's something measurable. Even though it's constant, you'll never get that stored joule output to the fence, but it's a constant. Just like horsepower on a tractor.
So, Jeremy, you know, like how we test, say, an alfalfa variety or a corn variety, we put them under the same conditions, and then we measure yield or whatever. Has anybody ever done that with fence chargers? Have they ever put like 10 different brands of fence chargers together, put them under the same condition, and then rated the joules or the output joules?
I think it's done within companies, but it is done at a specific load. So you can take a 10 joule Energizer of 3 different companies and put that under a specific 1,000 ohm load or a specific 500 ohm load, and then look at the analyzer, and the output voltages should be fairly similar, but again, you've got all different technologies inside each individual Energizer from each individual company that may have different capacitors, because capacitors are a huge difference. Morgan, do you want to?
I would think of it like engine horsepower and PTO horsepower. So your dynamometers can tell you your joules stored, and you're going to get as close as you can to that on your output side, but there's always going to be different mechanisms between that and the PTO where the actual power comes out that you use
Yep.
most of the time.
So what we're really interested in is, well, I mean, stored joules is important, but I mean, we're interested in what's going on in the fence, right?
Right.
But you can't measure it well.
But it's not anything that can be, when we're talking about looking at a packaging, then the stored joules is always constant across every brand. It never changes. So, yeah.
But the problem is you don't know what's getting on the fence with the stored joule, right?
You don't know what's getting on the fence with the output joules either, because the load changes from fence to fence. So your output joules are all over the place, but stored joules always stay the same. So that would be the most accurate way to compare between Energizers is the stored. That is the ultimate total in a perfect world, 100% efficiency. That is the peak, and the peak never changes because it's the peak. You can't go higher than the peak. So if we do have something to analyze and test, you would think then that some universities or companies or other governmental organizations could say, okay, we can measure stored joules. We should be able then to say X number of stored joules will do so many miles of fence. And unfortunately, there's no machine you can plug an Energizer into that'll just spit out some kind of equation and say, okay, this 10 joule Energizer will do 5 miles of fence. But some universities because if we just leave the companies alone, because companies want to sell you something, they want to market you something. So let's just put the companies out of the equation, look at universities and USDA. They have some ideas of how many joules per mile of fence is a guideline, but even within our land grant and USDA system of engineers, nobody can really come up with a general consensus on how many joules per mile. So you see it's all over the board, from 0.2 to 1 joule per mile to 0.3. So the real answer is it does depend on the individual fence, the individual situation, how the system is put together on how many joules will do how many miles or how many acres of fence, because in Muhlenberg County, my fence, that could be the same amount of wire as what Buddy's got in Kansas, but in the same Energizer, but I've got a bunch of bad connections. Bunch of just loosely wrapped connections. I've got some rusty pieces of high tensile wire that may be 35 years old. I've got some yellow insulators that are starting to crack and bleed through. And then Buddy's fence, same mileage on the same acreage with the same Energizer, may be a higher voltage, may be more effective because he's using good components, good joint clamp connections, a good ground system. So it depends on the situation on the ground. Does that make sense? Yes, and that ties directly back to your ground system. So we can get by with a rusty piece of rebar in West Kentucky for a ground system for a couple months out of the year. May get by for a couple years on a rusty piece of rebar and keep cattle in until the time that we don't. And then once that rusty piece of rebar fails because it's not a good conductor to transfer the shock back to the animal, then we say, well, should use 3 ground rods, 6 foot deep, 10 foot apart, like was recommended. So soil conditions change. That's why you need an effective ground system, and we'll get very deep into that, or try to, in the field. Joules are like horsepower, voltage is like RPMs. We're going to give you a pretty good overview of the joules and how they equate. And she explained to you about voltage and pressure. So water and electric fence concepts are very similar, but you can also, from another practical view, you can compare voltage like RPMs on a tachometer of a tractor, which is easy to measure because we can measure RPMs with a tachometer, and we can measure voltage with something as simple as a $35 plain voltmeter. Joules we cannot measure as easy. Horsepower we cannot measure as easy without a machine that specifically will analyze horsepower, just like a machine that specifically analyzes joules. But what we can say is you can take 2 tractors, one 300 horsepower and one 30 horsepower. You can put them side by side out here in the test plots across the road with a 30-foot disc behind both of those tractors and pull the throttle back, and they'll both run the same RPMs. Just sitting still, static, nothing happening. You can take a 28 joule Energizer, like the station has, and you can put it next to a 1 joule Energizer, and the voltage will be the same on both of those, testing at the terminals. Relatively the same. Actually, the 1 joule may be higher voltage than the 28 joule at some points, just a dead, no load, sitting there idling away just like the tractors. So then you take those 2 tractors that are sitting over in the test plots and you start driving around with the disc. RPMs will fluctuate a little bit because the wheels rolling cause friction. So when the disc is not in the ground, it's still picked up. RPMs will stutter a little bit, and both will run similar RPMs, no load. Hooked to a fence, hooked to a disc with no load. Take the 2 Energizers, 28 joule, 1 joule, hook them to a fence that's not really loaded, no weeds and grass, maybe a 3 or 4 acres worth. And my voltage may be 7,000 on one and 6.9 on the other. Remember, big Energizer, little Energizer, big tractor, little tractor, RPM's the same, voltage the same. The minute that I raise the wheels up on that disc, driving through the test plots, I can watch the RPMs on the big tractor pulling the 30-foot disc stutter a little bit, maybe go from 1,800 down to 1,600 and then level back out, and the tractor roll a little black smoke and just keep on rolling. Dirt turning up. Extension specialists running crazy, wondering why I'm disking up their test plots. Take that 30 horsepower tractor, pick the wheels up on the disc, you go from 1,800 RPMs to what's probably going to happen with a 30 horsepower tractor and a 30-foot disc. RPMs are going to bottom out, and it's going to stutter and cough a little bit, and it's going to die in the field. Can no longer pull that load. Same thing happens with the Energizer. The larger Energizers, when you load the fence, when you pick the wheels up on the disc, when you add weeds and grass and a few faulty insulators, you add leaks. Not necessarily a short, because you can short out the 28 joule Energizer with a screwdriver or a piece of old wire that falls over from a fence next to it. You can short out, but leaks, as you add those leaks, the voltage will stutter a little bit and then come back up to a manageable level. The extension specialists in most land grants will tell us that 3,000 to 4,000 volts to control cattle. Same on horses, sheep and goats, 6 plus, a little harder to control. So we can still maintain that 3,000 volt level or higher with a larger Energizer relative to the load on the fence, which can constantly change. When you pay $1,000 versus $100 for a fence charger across any brand, you're buying joules. That's what you're paying for horsepower when you buy tractors. Now you may pay extra for a cab tractor, or extra for a tractor that's got GPS built into it, just like you may pay extra for an Energizer that has a digital readout built into it or Wi-Fi capabilities, but ultimately you're buying joules. That's what you pay for. Don't have to get too deep in the technical terms. Power supply options. 110 volt, battery, and solar. Those are the 3 basic options on power supply. 110 volts always the most cost effective because we're buying what? What are we buying, Matt? Buying joules. The more I can get more joules for less money with a 110 volt plug in the wall, because we don't have to worry about the battery. We don't have to worry about the solar panel, the technology built into the solar panel that manages the battery and the discharge and recharge. So 110 volts always more power for the money. Always use that as possible. Now, the middle of the road alternative would be battery only. There are several Energizers from several companies that can go battery or 110 volt with a simple little inverter box. You plug it in one for alligator clips to a battery, plug in the other where it plugs in the wall for 110 volt. Transformer works the same way. The inverter box just steps the power down to 12 volt. So there are now an increasingly high number of 110 volt Energizers that are actually 12 volt internal components, and on the plug-in there will be an inverter. Is it an inverter? Is that the proper name that would convert 110 volts to 12 volts that the Energizer can use to then transform to low amp high voltage? So battery Energizers, if I use battery power, I'm going to have to swap out deep cycle batteries in a rotation more than likely. Deep cycle batteries are what's recommended because they're made to take a deep discharge, recharge multiple times, and last longer. But deep cycles cost more, so I got a little bit of added cost to the battery only system, even though the Energizer may not cost that much. I've got that deep cycle battery. equation. Solar is obviously going to be highly portable, but it's the most cost per joule because I'm paying for the technology, I'm paying for the extra battery, and most of those will come with a gel cell battery. Most of the readily available ones will come with a gel cell battery in the back of the Energizer. Well, that adds cost to it. And also keep in mind, if you're going to do large acreage, so we're talking 75, 100, 300 acres, you can do it with solar, but you're probably not going to do it with solar that has a gel cell battery made in the back of it that's ready to go off of the farm store shelf. You're going to have to go to a larger battery Energizer that runs off of one or maybe two deep cycle gel cell batteries, so the $200 outfits, and then use a bank of solar panels, maybe up to an 80 or 100 watt solar panel to keep. So you just made yourself a solar Energizer, but you've done it using a battery Energizer and a battery and a solar panel. But the self-contained solars are always the most expensive, and these are always the ones that make producers mad because they think when they go to the store with a $200 budget that they can spend $200 on the plug-in Energizer and then have to go through all the trouble of running a piece of underground cable from conduit out of their barn, 50 foot across the barn lot that they keep mowed with a lawnmower to get to the fence. All that trouble, run underground cable, the whole bit. Or they can spend $200, which they work just as hard for, to budget that $200. They can go pick up the solar Energizer and stick it right on top of the T-post and put their ground rods right there next to the fence and clamp it to the fence in a 2-foot lead out. They're getting less power for the same money with the solar. In cases where 110 volt can be used, always use it. That $200 that you budgeted, or $500 or $1,000, you're going to get more power for that same money.
What's your biggest solar that you make? How many joules would that be?
28.
So you actually have a solar charger that's 28 joules?
Yes. The one that you have in the little shed in the Energizer box, that is an MB, and now the new labeling is MBS 2800i. So a MB 2800i is mains and battery 2800i. So in the box it came with a set of alligator clips because it's a 12 volt internal. It runs off of 12 volt, and that box converts it from 110 to 12. Then the Energizer spits out the conversion. So it's a 12 volt Energizer with a 110 volt converter. You unplug one tip and you plug in the two battery leads, and then you have a battery Energizer and one extra component, which would be a 90 watt, in this part of the world would be I think 110 watt solar panel that has a regulator built onto the back of it. You set it on the post and screw it in, plug your leads into it, and then leads come out of it to the battery, and now you have an instant solar Energizer, 28 joules.
So how much would it cost to get that 28 to solar over the cost of the Energizer?
An extra $800 to $1,000. Is that right, Jerry? For the solar panel setup with the regulator. So an extra $800 to $1,000 plus the cost of your batteries. So now you've doubled the cost of the Energizer, literally, because that's probably a $1,000 Energizer.
If you had to rate the reliability of the solar versus the plug-in, which is more reliable?
Both. It's.
Well, wait, that sounds like you're selling Energizers.
It is. I mean, so if before, in my county, before 2008, before the ice storm, then I could almost say that a very well-built solar system would be more reliable than Penny Ryle Rural Electric in southern Muhlenberg County. Yeah, and then after the ice storm, it's a different story. Now the power grid got rebuilt and 110 volts, so it's relative to your input power. So the Energizer itself would be the same, because that same exact Energizer I can spend $1,000 on and make it solar. And the technology is still the same of the Energizer. I just have to worry about either my batteries going dead because I bought cheap deep cycle batteries, or I have to worry about, in that case, the rural electric co-op that covers Caldwell County not giving me good service to keep the 110 volt power on. So the technology would essentially be the same in that case. So it would be as reliable either way, depending on your input, whether it's 110 volt plug in the wall or cheap batteries you plug the alligator clamps to.
So what's your life expectancy on a 110 watt solar panel?
That we don't know.
What?
Tremendously, yeah, tremendously more than it used to be 15 years ago when I started with this company. Tremendously more. I mean, look at all the technology.
It'll keep working past there, but it won't work as well. It'll keep deteriorating until you don't get enough charge for your battery.
So Morgan, can everybody hear what Morgan said? Say it one more time, but louder, Morgan.
Newer solar panels, realistically, you want 10 to 15 years. They're going to last 20 or 25. They're going to keep deteriorating, and they're not going to charge your batteries out at 25 years. They're just going to keep getting worse and worse. So I would put 10 or 15 years on it and expect to have to do something.
The Energizer industry has been very effective in bringing the efficiency of solar panels and all.
If you were to take that 110 and put it on 120, how long do you see or can you expect? And I know it probably depends on load, but that one charge of that battery can hold up, not collecting the solar.
It would depend on the load of the Energizer. So potentially, I could take the battery out of my Gallagher wagon and plug it up to the station's Energizer, and it might run for 3 days, just pulling a number out. It may run for 3 days with just battery only, no solar panel hooked up. Or I could go to the John Deere place and buy a gel cell deep cycle battery and plug it up, and it may run for a week. Or I hook it to a rob a lawnmower battery off of something out here at the tool shed and run it for 6 or 8 hours. So it's,
If you have a good battery, what you're saying is if we have a couple days with limited sunshine or shorter days in the wintertime, it should handle that all right.
oh, absolutely. If the Lord lets the sun come up, you will get charge. So if there's a day the sun doesn't come up, then my fence is the least I'm going to worry about. I mean, obviously, you can see I'm not the most tan person in the world. I can go to Florida and get absolutely fried on a cloudy day. You still get UV ray. You still get rays from the sun through clouds. And on a cloudy day, you can still charge. You can still get charge out of the solar panel. I can go out in a nasty, dreary November day. Now, I don't get as much light daytime length in November or December. I guess December would be the ultimate short day. But I can go out in December on a dreary day, take a voltmeter, unplug it from the battery, put a multimeter on the hot and ground leads to the battery, and still read voltage. And in a lot of cases, it's going to be over 12 volts. If it's a 12 volt panel, it's going to be over 12 volts in the clouds. It's not as efficient as on a bright sunny day, but the solar panel still charges if the sun is up.
A rough cost estimate, you would double the cost of the Energizer by adding a good solar panel and good battery.
Yes and no. In the case of the one at the station, because the bigger the Energizer, the cheaper the joules become. So in that case, you would take a $1,000 or $1,200 Energizer, you would add $1,000 worth of solar panel and maybe another couple hundred worth of battery. So now you've doubled the cost to make that 28 joule solar. But if you step down to a smaller Energizer where the joules cost more on a smaller plug-in, then you start adding solar technology to it, and you may increase the cost by more than 2x. So it's all incremental. A 28 joule Energizer does not cost 28 times more than a 1 joule Energizer plug-in. So one of the other things that we've done, Buddy mentioned technology and solar panels changing, and Morgan said now 15 years or so is what we can expect, 10 to 15. The other component to that within our organization, our engineers have now taken and built software into the modules of the solar energizer, which manage that transfer of power and discharge of power. So it's not just a solar panel that sits there all the time pumping out energy when the sun's out. There's technology, software actually built into the module which manages that discharge and also manages the recharge, even one step above what a $75 voltage regulator would be. So there's technology is, yes? No, and it would. Let me say this, and then Buddy's got something. On a typical, say, mid-range 3-joule plug-in-the-wall energizer, you're literally talking pennies per month. Pennies per month. So keep that in mind from cost savings point. Pennies per month on a plug-in-the-wall charger that you've paid 4 times or 5 times less for than the solar.
Yeah, I've been to farms where the farmers have to call the power company because they use something charged running there that can hear it and stick it with its meter. So you'll never get a, if that's all that's on the energizer, you'll never get above your base charge where that meter is.
So really, the only place to use a solar energizer is where you can't get one hit.
I would say that the cost output has to be on the infrastructure being put in to put power somewhere. That's where the costing out will come up, is if you have to run electrical lines. Pay for them yourself.
Yeah, or that $36 minimum charge every month if you're just running the Energizer off of a pole at the edge of your pasture and you're not running your tool shed or your anything else off of it. But when I'm talking pennies per month, that's literally pennies per month of what the added cost would be if you're already paying for the power service. We have a chart. Haven't seen it in a while. Maybe I need to put it in the presentation for fence schools as just an emphasis, but and this is going to be rough numbers, but so a 10-joule energizer, you're looking at about 12 watts of power. So that is 12 watts would be a fairly bright LED bulb. So you're talking about, what used to be a night light are now a single LED bulb like you would put in your ceiling fan. That's what a 10-joule energizer is going to pull. Then you get up into the 28 or the 58 joule range, then you're up in the 60 to maybe 90 watt. And that's just an example, which would be like burning a 60 watt light bulb all day long around the clock. And that's under a constant load too, because as your energizer changes and your watt usage would of course change a little bit, but nothing significant. So pennies a month. And you don't have to.
I would say 5 years of current trade travels continues, we would like a battery.
Yeah, especially with lithium battery technology. So that solar energizer, that is still a battery energizer. It's just got a solar panel combined with it. So you still got to have a battery, but one that just plugs into the tractor battery with no solar, that technology is pretty antiquated. Another thing to consider from an environmental standpoint, would be up to the personal analysis from each individual consumer, whether you're spending pennies a month off the power grid or you're paying a little more up front or a lot more up front for solar technology, but then the solar technology relies on a battery, and what's the environmental impact of having to recycle that battery every 3 to 10 years, depending on what type of battery it is. So there's some cost and environmental benefit analysis that have to be done. Morgan give you a very in-depth explanation on how the animal gets shocked with a hot system and also a hot ground system. So the practical uses of a hot ground system are, the effectiveness of it is very effective. On a hot ground, you would have alternating wires, hot and ground, hot and ground. Now those alternating wires must be grounded all the way back to the Energizer where your ground system is. When you drive around anywhere in Kentucky or Tennessee, and you see these 5, 7, 9 strand high tensile fences, and only 3 or 4 of those wires have insulators on them, then there's 1 or 2 things going on. If it's a 6 strand fence and you see 3 insulators, then you're either using the other 3 wires for a true ground, which then must be connected under every gateway, just like your hot wire. It has to be traced all the way back to the Energizer, to the ground system. That's a true hot ground. Or the other scenario is there's a 6 strand fence, 3 wires are actually hot, carrying capacity to shock the animal, and the other 3 wires are sitting there just holding the earth together, wasting resources and power conductivity, possibly. Because if those other 3 wires, in that case, are not grounded to the actual ground system that is hooked to the Energizer in a constant circuit, then that system is not a true hot ground. It is not anywhere near as effective as a true hot ground. Now you can go randomly drive some ground rods around the farm and hook to that neutral dead wire and may do a little bit of good, but you're much better off to, if you're going to do that, you're much better off to make them all hot. Matter of fact, you can make that fence twice as conductive if you take the 6 strand fence with 3 insulated wires and then 3 neutral, not really grounded wires, and make those 3 insulated. You've doubled your conductivity of the fence. You've cut your resistance in half. So a 6 strand fence with wires that are not hot and that are not actually grounded to the ground rods hooked to the Energizer, that fence, there's a lot of things going on there that could be improved.
So do you have to upsize your Energizer if your 4-wire fence, say, and you got 2 of them hot, 2 of them not, but you want to make them all hot, you would have to upsize your Energizer?
Technically and theoretically, no. You could downsize your Energizer by making 4 wires hot instead of 2, because if I go to each end of the fence and connect those wires together in parallel, the Energizer looks at that as one big wire. They have to be connected in parallel. And Morgan said electricity travels around the outside, so that's more surface area I've added, which makes the fence more conductive. So if they're paralleled, it would actually be easier to electrify. 4 strands of fence can carry more power for longer distances than 1 strand of fence going the same distance. So 4 strands is more conductive than 1 strand. 4 strands is easier to electrify than 1 strand. So if I've got that 6 strand fence and 3 of them are hot and 3 of them are just neutral, dead, holding the world together for no reason because we saw the neighbor do it or that contractor saw the other contractor do it just to add wire, if I electrify those other 3, I've just doubled the conductivity of my fence. I've cut my resistance in half.
So you have to tie those wires together at each end of the run, not just one, right?
Every time you stop and start. So if you get to a brace assembly and you terminate the fence with insulators, then you have to jump those wires together. The Energizer then looks at it as one big strand instead of going out. Like this case, if I went to the end out here and just had 3 wires tied off dead to insulators without this component, without that, then the Energizer would look at that and say, okay, I'm electrifying 1, 2, 3 wires for a mile. That's 1, 2, 3 miles. That Energizer thinks it's electrifying 3 miles of fence. If I join those 3 wires together at the other end, just like you see here, the Energizer then says, okay, I'm electrifying this big wire for 1 mile. It has no idea it's looking at 3 wires because they're joined in parallel, they're paralleled. Very easy way to get more power or more conductivity on your fence. Did I explain that in the best way? Okay. And there's another slide that'll make it a little more sense here in a minute. Grounding. This is the heart and soul of how the animal gets shocked. This is the heart of the fence system. The recommendation from most land grants and NRCS and most companies is going to be 3 ground rods, 6 foot deep, 10 foot apart. That's the minimum recommendation, with the exception of a portable Energizer and 1 roll of poly wire. We can get by with a T-handle ground rod on short distances. But that ground system is the antenna. That's how the animal gets shocked. It's the ground system, those 3 ground rods, 6 foot deep, it's just sitting there like an antenna waiting to pick up a signal of an animal touching the fence. Now, a rusty piece of rebar is not a very good antenna. 3 ground rods would be like having a satellite dish compared. One of the hardest concepts for us to get producers to overcome is not to use copper wire with electric fence ground systems. Don't use copper wire. Copper is a wonderful conductor. It could be one of the easiest conductors that we can come up with, wouldn't you say so, as far as readily available? It's a great conductor. Copper conducts so well that it hates other metals. But if I take a copper ground rod and connect a galvanized wire to it and put electricity through it, because the ground rod gets hot when the animal touches the fence. If I take a copper wire or a copper rod and a galvanized wire and join them together, run electricity through it when the animal touches the fence, then electrolysis will happen at that connection. If I take a copper wire, a copper ground rod, and then chuck that up into a galvanized fence terminal, 2 different types of metal, copper and a galvanized terminal, run electricity through it, whether it's on the hot or the ground side. If I'm using copper for a lead out, then I'll get electrolysis there and it'll eat the galvanization right off and it'll just eat the galvanized steel up. 2 different metals, so never join copper with other metals. Don't even do it with the dielectric grease and all these pastes and salves and whatever the electricians use. Just stay away from it. Use galvanized wire, galvanized rods, a galvanized or a brass clamp. You're going to have galvanized fence wire normally, especially on permanent fence. It'll be galvanized high tensile. Use a galvanized wire to lead out from the Energizer. That keeps everything the same. And you don't have to worry about electrolysis as bad. Lead out, we'll talk about lead out and show you some examples in the field. Always use a lead out that is the same or larger than your fence wire. So I would never want to electrify 12.5 gauge high tensile with a 16 gauge smaller lead out wire. And the longer my lead out wire becomes, the more resistance there will be. And I may have to, in some cases, even use 2 lead outs. If I'm going a long way to electrify a long section of fence or a large acreage, then I may have to use 2 12.5 gauge lead outs. It's a factor of distance and resistance both. The main thing is, do not use a small 16 gauge lead out wire on high tensile fence. You never would start out with a 3/4 inch water line and run across the farm and 300 foot before you get to a mirror fountain, put a 2-inch line on the system. You always start out with your bigger water lines and go down smaller. So you always start with your big wire and go down to smaller. So you would start out with your 12.5 gauge lead out to a 12.5 gauge electrified fence system, and then drop down to your poly or turbo wire for your cross fences or temporary fencing. So this puts it in a little better perspective of resistance and wire. Let's take a single strand of 12.5 gauge high tensile is 56 ohms per mile. That's one strand, 56 ohms per mile. Morgan got deep into the weeds on ohms, so that's resistance. 0 ohms would be wonderful because there's no resistance on that wire. Electricity can just flow freely down through the system. We're never going to get to 0 ohms in a farm setting, or any setting probably, to get to 0 ohms. But we're looking for 0. We're looking for no resistance. We're looking for no crud and buildup inside that water pipe to slow down the water flow. So one strand, we're at 56 ohms. If we take 2 strands of high tensile wire, connect them in parallel, our resistance is now at 28 ohms. If I've got a 4-strand fence, 2 of them are electrified, I'm at 28 ohms per mile. Are you following me? If I take the other 2 strands that the contractor left as neutral with no purpose because they're not grounded to anything, and electrify those, now I'm at 14 ohms per mile. Is 14 ohms per mile less than 28? This is twice as conductive as the 2-strand. It's easier to electrify. I can go further distances. They have to be connected in parallel, jumped up and down at every stretch where it terminates. What's that? So polywire is around 10,000 ohms per mile. 6-strand stainless steel polywire is around 10 to 12,000 ohms per mile. And we'll show you a real world example set up here in a little bit.
Just remind us that resistance is your enemy in electric fencing, right?
Yes. Resistance is your enemy unless you're talking about wires. And if it's your conductor, you want little resistance. But if it's your insulator, you want a lot of resistance. So your conductor, you want little resistance. So we can take the 6-strand polywire at 10,000 ohms per mile. We can take another wire, a high conductive, maybe 9 strands, and it may not all be stainless. We may add some better conductors, some better, more conductive metal in those 9 strands, and go from 10,000 ohms per mile to 200 ohms per mile, which is more conductive. It's getting closer to 0. Matt, did you have?
Yeah, I'm struggling with this one, and I think you give me good advice. So, on some places where I, section off, use the same reel, same 1,000, 1,200 foot poly, or turbo, or, whatever. Would I be better to have a short reel for a short section? Do you lose that much voltage if you got all that wire running on that reel or not?
I don't know if there's any, I've never noticed that, and I would think that it would make no difference at all. Do you have anything from a scientific standpoint if you've got?
Wires together, right?
Yeah.
Instead of being stretched out.
And if it's turbo wire anyway, then you can't get much more than 1,000 or 1,300 feet on a reel. And at that distance, it's still extremely conductive. You're not losing much from resistance. And even on plain poly, if you were using just the cheapest 6-strand stainless steel, whether you've got it all, even if you had it all stretched out, you're still within that 1/4 mile, 1,300 foot threshold where poly starts to drop off. So you don't lose by leaving it on the reel. Companies that sell reels would appreciate if you would buy multiple reels and maybe have one reel for this 800-foot field and another reel for this 300-foot field. We appreciate that. So maybe that would, try that and let us know. Protecting your investment, we're going to show you an example of a very simple lightning diverter setup that is adjustable. So once upon a time, a few decades ago, you could get a lightning diverter. You can still buy a lightning diverter that is a piece of porcelain with 2 terminals on it. Inside that porcelain, you have a metal connector. One side's hot, one side's ground. There's a preset gap. That preset gap was great when everything was a small powered Energizer from 80s technology. With the larger technology, larger Energizers, that preset gap in that porcelain thing may not be sufficient. Because that's the gap between the hot and the ground. You want lightning to jump that gap and go to the ground instead of running all the way to your fence energizer and blowing it off the wall. So the adjustable diverters, you can actually adjust that gap between the hot and the ground according to energizer output and conditions with your fence. So adjustable diverters, surge protectors. If you're going to spend $1,000 on a fence charger, then a $25 or $30 surge protector is kind of a no-brainer. It's protecting your investment. Because we used to see, we don't see as many in our repair shop in Kansas City, but we used to see a tremendous number of energizers that would come in that were damaged because of power surges. Now, over the last 40 years since we've really been operating in the U.S., the power grid has obviously gotten better, and we don't see the amount of surges we used to, but surges are definitely a threat on 110 volt. An adequate ground system. The better the ground system, the more lightning protection you have. Layout, how are we on time?
Well, it's 11, but our time's a little flexible for this training session.
Okay. So layout, when designing a permanent system or a temporary system, the layout needs to start on the notebook or the computer or phone screen before we just go out to the field and start running wires, especially on permanent fence. So plan it out. There's a lot of tools we can use now to make planning fences a lot easier, a lot of free tools. Think about future expansion on permanent fences. Do you want to add cross fences in the future? If you do, would it make sense to go ahead and build your perimeter fence and then use temporary fence for your cross fences and see if your animal flows work properly? So use temporary for a few years and then come in with your permanent multi-strand cross fence. Also power flow. If we've got a system that is cross fenced, do we want power just flowing every which direction, or we want to think about it and have maybe a main central trunk to distribute power to the smaller paddocks that then dead end to make it easier to fault find? Because if we do have dead ends, then it makes it much easier to find faults instead of everything just being hooked together, which is fine. You can hook everything together. You can have complete circles being made in your pasture with fence. And there's nothing wrong with that except it makes fault finding harder. Unless we get into a 500-acre block, then there needs to be some power flow considerations drawn out ahead of time. I like to use polywire for a few years before cross fencing. It just makes sense because you can move that temporary tread-in or pigtail post a lot easier than you can move a 6-inch post that's got 3 strands of high tensile on it if something didn't work out. Some easy tools that are basically free in every case. You can go to the FSA office and have them print off maps. Your producers can go to the internet and pull up Google, and now Google Earth or Google Maps, if you switch over to the aerial function, has got a very easy drawing tool where you can draw footages. You can actually look at footage or miles, either one. That's pretty handy when it comes to cross dividing pastures, because if I know I've got about 1,000 or 1,300 foot on a reel, I don't want to take out across a pasture that it's 1,500 foot long and then have to splice wire and add to it and so forth. So this is an example of the Kentucky Commonwealth Map. I use this a lot. You can actually save the maps and go back later and pull them up and modify them. But this slide is in your handout, in your binders, and very easy tool that you or your producers, either one, can pull up. And you can do a lot of things with the Commonwealth Map. You can look at, I actually used this one time. We built a house in the middle of the cow pasture and had no idea where the water lines were when we put in mirror founts 12 years ago. And I went back through the Commonwealth Maps, which has several years of aerial photographs stored in it, and started looking back at aerial photographs from 2003 and 2004 and 2005, and was able to see my old water trend. Because when you dig a water line through the middle of a pasture, it's going to show up for a couple of years in aerial photographs. So I was able to get some kind of an orientation where those water lines went. But otherwise, you can draw out paddocks and get your acreages. If you're trying to do rotational grazing or managed grazing, you can get your acreages ahead of time. So if you've got a consistent forage base, and you know you want to allow your animals 3 acres, because that gets you through 2 days of grazing or 3 days of grazing, then you can consistently draw out 3-acre tracts all over that field. So definitely give that a go. And there's an example of just drawing an arbitrary square out in the middle of the pasture and getting your fairly accurate acreage ready. And that's in your handout. So a couple things to keep in mind. Use larger wire if possible. So 12.5 gauge conducts more than 16 gauge. Multi-wire is better. Remember that 7-strand fence that has 3 strands electrified, I can significantly increase the conductivity if I electrify all 7, or maybe I could have made a 5-strand fence to begin with, save the money instead of adding those extra 2 strands that serve no purpose, other than maybe a little bit of a visual barrier, but we're still working off the psychological effects. So that 5-strand fence all hot would have been just as productive. Don't mix metals together, copper and galvanized. Think of it as a system. It has to work, all parts have to work together for it to be effective. We can dehydrate with the new technology, the larger energizers. We can dehydrate weeds and grass, but it gets a point where, especially during the spring flush, you can't perform miracles. There's a point you're going to have to do some type of mechanical or chemical control. Now, with how big is this demo field out here that we're?
Probably about 25 acres or so. And then there's another, on that same Energizer, there's another 20 acres on top of it.
Okay. So out here we've got a 28 joule Energizer, which realistically would be great for 250 or 300 acres. Now the rating may say 700 or so on the packaging, but a couple hundred acres, 28 joules would realistically do with some moderate maintenance. But what we see out here is 20, 30 something odd acres cross-fenced with offsets and multi-strand cross-fence that has had 0 mechanical or chemical control, and we're still maintaining a very effective 6,000 volt threshold. And you can, today when we walk down the main lane, you'll see where the grass is dehydrated. So we've overcome, by throwing more power at the fence, we've overcome some of the need for mechanical or chemical control. And that's always a reality, but it's all relative to what time of the year, how much grass. Is it poke weeds or is it tall fescue? How many joules are you dehydrating it with? Because I could put a 1 joule Energizer on that fence. We've got a 1 joule solar today that we're going to use for the polywire and high conductive polywire demonstration. I could put that 1 joule Energizer on that 25 acres and it worked flawlessly. But right now with all that grass growing up on the bottom, it would probably be struggling. But normally if I did a good job of keeping that spring flush down, no problems at all. So it's all relative. We'll talk some more about insulators, good quality conductors, and some easy places to find problems. Using poor quality materials or poor quality workmanship and crazy, silly concepts like this, using rusty wire for gate handle, for transferring power across gateways, and these rubber tube insulators that crack. I mean, none of these things should be done and then the producer expect to have an effective fence, because there are better methods than cobbling a bunch of junk together like this. When it comes to temporary fence, reels, and polywire, that was actually a person's fence reel, that antifreeze jug, and that was actually in Kentucky. That was up in somewhere around Boyd County, Flemingsburg, in northeast Kentucky, and that was a fence reel. Now, using polywire and an actual reel made for fence would make it a lot easier to store the wire on, but don't do silly things like that and then expect the system to work well. Just some more examples of things that can happen by using low quality materials or these substandard wraparound rubber tube insulators. This man had a gate that would just eat you alive. Also, just some in general things when it comes to planning. If I'm building so this is an offset. Well, no, this is not an offset. This is an electrified wire that is put above a 53-inch high woven wire fence. So a 48-inch woven wire fence that's boot top off the ground, so about that high off the ground. And then this person has went above that and put a single strand of electrified wire. And this was for cattle. So good separation. We're not going to arc electricity that far from the woven wire to the high tensile. But there was something failed on this fence, whether it was the strainer or a tree limb had failed, something caused that strainer to lose its straining capacity, and now you have that electrified wire grounding out on the woven wire, which is bad. But what's even worse than that is this man has no idea why he put an electrified strand at 53 or 57 inches tall, because his cattle, their noses are this tall. So when you plan that out, why in the world would you put why would you put a barbed wire even at the top of a woven wire physical barrier? Much less, why would you put an electrified strand up this tall to keep cattle from pushing on the fence? So that's just an accident waiting to happen. Plus, it serves no purpose. I could have went down to waist high or pigtail tread-in post height, like we're going to see out here on the research field with an offset, and been a lot more safe from shorts, and also served a purpose to hook into for temporary fencing. So think about that. Every time you drive down the road now in West Kentucky and you see a woven wire fence with a hot wire on top of it or a barbed wire on top, then now question, wonder if that person really knew why they did that, or if they saw the neighbor do it, or it's always been done that way, or maybe the contractor couldn't drive post straight, so he strung out a piece of barbed wire first to line up the post, and he wouldn't have to reel up his staging string. Who knows? So there's a lot of crazy things that are done for no reason. Is there anything effective about either one of these pictures? I mean, this is real world stuff that happens, and people wonder why their electric fences don't work. And I would dare say that many of you may have received calls or talked with producers before that say, I phooey on all this stockpiled fescue grazing and rotational grazing. I can't get electric fence to work for me. My cows won't respect, never stays hot, won't ever work. I'm just going to open all the gates and let them run free. Within the boundary, of course. How many of those same producers have setups like this or like this? There's probably a reason why they don't have good results and are not delighted with their power fence system. I know the UK experiment station over in East Kentucky was not delighted when their fence system didn't work and they had this cobbled up mess. So. Yeah. So, knowledge is power. There's always a chance of a short happening, a tree falling on the fence, somebody run off the road, run through your electric fence, causes a power failure or a structure failure. There are ways to monitor that, very easy ways to monitor that now, using simple, what used to be complicated technologies now become more simple. So now you can have a Energizer system with monitors that are set around the farm. So a monitor that's just like a person holding a tester. And then you can have your Energizer hooked into a Wi-Fi gateway that when one of those monitors detects a voltage drop that you set, so you can say, okay, that section over there is my bullpen. If my bull lot ever drops below 5.3 thousand volts, I want to be alerted. Then you can get an instant text on your phone through a cloud-based app that says your bullpen is now at 3.2 volts. or we've lost communication with your bullpen, which means somebody either drove a truck through it or stole your Energizer or stole your monitor. So there's ways to find out problems almost instantaneously with your power fence system. And this is developed because producers want to be in the know. They want to know what's going on with their fence. They want to be in control. So we've got most of the day left for questions or thoughts or